And with that,
we go live, and that's
okay, everybody. So, for today's stream, we're basically going to continue where we left off yesterday. I think the first thing we're going to try and do, which we should have done, honestly, a week ago. Sorry, no, what am I doing? No, drawings. Oh yeah, drawings. So Google Drawings has a unique feature, which is that for every other Google Docs app, you do, subdomain dot google.com. So you do like docs.google.com, sheets.google.com, right? /create, and that makes you a new one. And if you don't go in /create, you go to the listing, right?
Yeah.
For Google Drawings, there is no listing, and /create goes nowhere. But if you write drawings.google.com, it makes a new one.
Of course.
Because expletive, that's why.
Yeah.
Yeah, it's amazing. It really is. Okay, so so we're gonna today. What we're gonna try to do today. Okay, maybe let me take it back from a start-ish. We're making a way to define workflows for large language models. Now, we could code that using code, but that will be too simple. So, what we're going to do is we are gonna design a code generation strategy or workflow, to be more precise. We're gonna design a code generation workflow that is competent, that can generate a workflow library that is capable of expressing this code generation workflow.
Yeah.
I think those are all the words in the right sequence. So the idea is that if we will define a strategy, we'll try to run the steps by hand to generate the workflow. If we are having trouble and we need to adjust the strategy, we go back and fix the strategy, try again. If we find that we need some more features in the workflow, we edit the requirements for the workflow engine because obviously we found another bug. But the long and the short of it is that this gives us an incremental path towards creating this kind of self-hosting workflow library. Now, we've already done a number of experiments along these lines in the last few days, so we kind of know what we're doing. But undoubtedly, until this thing actually works, we're going to have a good number of surprises. Ryan, do you want to add any thoughts?
I think that covered it.
Cool. Okay, so what we have so far is that we start with a prompt, right? I know I'm making it sounding really incredible so far, and shocking. Nobody really has ever thought about prompts before. So basically, then we have pretty much figured out. Wait. So the first prompt is, that's what I'm trying to do. Whoop. So you've got requirements. What was the first?
So we've got check for conflicts.
Right, yeah. Logical contradictions, I think, yeah. Okay, let me shrink the font a little. There. Right?
Right.
And then you've got a self-referential little loop there, by which I mean you if it finds any flaws, you fix them, presumably. Oh yeah, that's the yes flow, I suppose, right? And then there's the no flow, where you basically say, okay, well, can you ask any questions that might... How do we articulate these questions usually? The sort of clarification issues.
I say ask any questions about the requirements with the goal of uncovering unstated requirements.
Yeah, let's actually look at what we've been doing. There we are. Okay. Yeah, so what were my original requests like? Oh yeah, there you go. Right?
Yeah.
So the importance of those, that wording is that it gives me a baseline. Like if I can say, like, if the importance is below 6 or the uncertainty is below 4 or whatever, then ignore, right? Because it's always going to make some questions. But the question isn't, does it have questions? The question is, are there any sort of important, serious questions, right? For whatever serious means. So that's how I found to sort of work around the fact that if you ask it for questions, it will ask questions.
Yeah.
Right. And the point is, like, we have to sort of figure out what the threshold is. And sometimes, honestly, anyways, yeah, sometimes the solution is so straightforward that even for simple ones, I would just kind of accept it. But I think the most important thing is that things that are important and things that it is really confused about, that they are resolved.
Yeah.
Yeah. So generally, when I did that, the other thing that I did, is that I would ask it to suggest its own answers to this.
Yeah.
So, I think this one has it. Okay, so just answer the formal requirements that should be either modified or added. Right? And it's like blah 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 blah. So then I could say like, accept this or this or this. Right? So for each, like, you could always do this because it's very easy for a user to say, yeah, this is what I meant. Right? And often the LLM will have the right interpretation. It's just not sure. So all you can, like, with a thumbs up, you can improve your requirements quite a bit.
Yeah.
Right. So let's get that in the mix. Okay. Now, in principle, we should be ready to move on from here. But in practice, what you probably want to do is go back to this step, or maybe
Change tab.
this step.
Change tab for sharing.
Oh, sorry. You probably want to go back to this step, and then actually, when you're done with that, you want to go back to this step.
Yeah.
You know what I mean? Like you actually want to make sure you don't have any contradictions as well. And when you're kind of passing through both with flying colors. Now this is, look, I'll tag this as optional basically with dashed line, but I do think it's, if we're being strict about it, there's no point, but there's little point not to. Just to be sure, Anyway, but when you come out of all of that, right? So at some point, plausibly, you end up without you end up with a set of requirements, right? That are consistent, that the LLM is not confused about, at least not in anything that matters, basically, right? Right, and actually, this is important. There's a secondary element here, which is what we kind of said right before we started, which is that we want to have, basically and this is almost like a side quest, right? Like once it says any form of basically, yeah, you don't want that in a context at all.
Yeah.
Right, you just want that on the side as a confirmation of sorts, and maybe not everywhere. I'm just putting it there enough as this kind of sort of reminder, right? Yeah, that's probably the right way to do it. Right, something like this.
Yeah.
Okay. And are you sure again is a generic form of a more specific question that is relevant to the previous prompt.
Yeah.
Okay, so then you have these requirements, and then you say what? Oh yeah, yeah. I got it. That's when we go to the orthogonalization, right?
Yeah.
Right. Is this helpful?
Yeah. I want to get to the recursion because that's the main part that I think is going to be that's sort of the crux of whether this thing works or falls down.
Of course it works. What are you talking about? If you just wanted to know that, you could have just asked me. So this is, can you write the specification below such that every requirement is orthogonal to all other requirements, but no information is lost? Group requirements where it makes sense. Right?
Yeah.
And then, of course, are you sure? Trust no one. Okay. That's good. Yeah. Okay. Now, it will produce orthogonal requirements, right?
Yeah.
That's your next sort of output.
Now, at this point, your requirements have ballooned to the point where trying to get anything that hits all of them in a single shot is unlikely to work.
I don't necessarily think so, but could totally. It's definitely possible, but I don't think
my
it's
observational
necessary.
study. It's not double-blinded placebo-controlled study of requirement.
Very well done. Very well done. You've been paying attention to
My observational data indicates that this is the case.
Yeah. N equals 1. Is that the?
I actually it got so frustrating at one point I developed a second personality, so I'm going to say n equals 2.
But they both were using the same use case.
No, I mean this is actually across a lot of the stuff that we've done, right?
Well, I guess what I'm jokes aside, the reason I'm saying this is because
I want to coin a term here, right? Which I know is going to give you hives when I coin terms, but there's something akin to a soft context limit, a soft context size, right? You've got the hard size, which is where you literally won't get an API request through. But for a given task, even if you're well within the token limit.
Yeah, some sort of complexity. You mean some sort of complexity limit.
Yeah. Which is well below what the hard context size is.
Yeah. And I have thoughts on this matter that I don't know how to I have thoughts on this matter that I don't know how to articulate. Sorry, that I don't know if they're useful right now.
Okay.
but man, I lost the thread. What was the thing you said again?
There's a soft context limit, basically.
Right. Yes. So basically, if you think about code in the terms that we were thinking about it a while back, right, which is like a sequence of prompts that stack upon each other. Now we've gone back to like basically a single prompt. There's some complexity about how you turn that prompt into a good prompt and how you turn that good prompt into code, but ultimately it's one prompt, right?
Yeah.
There is some window, I think, of breaking that prompt into multiple prompts, but that passes by a process of deciding which features are essential and which features are like cosmetic, let's call it, like add-ons. As in, if you build a backbone on the basis of these features, then those other features can be comfortably added on top without penalty.
Yeah.
Does that make sense?
Yeah.
Now I think what's interesting is that which sort of requirements, I think requirement is a better word here, which requirements that is, doesn't depend on solely the requirements themselves. It depends on also on the other requirements.
Yes.
Right. So a requirement that is let's call it a leaf requirement in one context could be a core requirement in a different context. So there might be some process that you apply here actually, right, whereby you break up your big prompt, right, this orthogonalized prompt, into some sort of sequence of prompts where the first one sets up the backbone, and the second one sort of builds on that, and the third one builds on that. Like, just to give an obvious example here, like if you are making a web page, right, like the fonts you use like are important, right, but they could kind of be the last thing you add in most of the cases, except if for some reason font size affects, I don't know, page size, and page size runs into some requirement about layout, right, and then the font actually matters. Most cases it doesn't. So you can basically build the backbone of your website on the basis of something, and then you can layer the presentational stuff on top.
Yeah.
Anyway, so that's where I would, long story short, I guess this is what I would say, right? If we hit the complexity budget here, that's what I would do. I would try to figure out a way to at least shed some of the additional requirements, right? So that I'm left with a kernel of the stuff that can formulate about. Basically, like reverse engineer myself to a prompt sequence that makes sense, if that makes sense.
Yeah. The challenge, right, is that I really want to land at an algorithm that works without me looking at it.
Yeah, we'll get. I mean, we're not going to get there today, but we will get there.
Yeah. All right. So what do we do? Do we assume that? Do we put an asterisk here for sort of condense requirements to core with human intervention? If
Sorry?
we presume that process has to happen.
Sorry, say that again.
Do we put an asterisk here that's like human intervention to to shed leaf requirements?
I wouldn't. I would just leave it as it is right now, and kind of know that this has a complexity limit somewhere.
Right. Well, it has a complexity limit that we've reached with the thing that we're trying to build right now.
Do you think it's non-generatable?
What do you mean?
Do you think that our prompts are so complicated they can't actually generate working code?
I think they can generate working code, but they can't do it in one pass, right? We need to find out how, we want to go from orthogonal requirements to a usage example, type definitions, and an end-to-end test suite, right?
No, but I guess what I'm saying is that this is fine. What I'm talking about is a prompt at this stage that is so complicated that if you tell it like the first thing, make me a usage example, it gets confused. Like reliably, it can't make a valid usage example even after Smart GPT.
I think usage example will be okay. I think having a thorough enough end-to-end test suite that actually covers the requirements will not be. But we can break up I think if we have the usage example and thereby have the type definitions, we can parallelize the generation of the end-to-end test suites.
I don't understand. What I'm talking about here, you raised the point that there is some sort of complexity limit, right?
Right.
What I'm saying is the complexity limit that I'm talking about is the complexity limit where we can't get from here to where we want to go. And for me, that's the complexity limit where, the next thing you want to do from here, which is, for example, make me a usage example, after, 10 attempts, it just can't do it.
Yeah. Okay. Then I don't think we're there at this step.
Great. That's what I'm talking. I'm talking about the sort of thing where it's, the whole thing is so, involved that the LLM kind of loses track basically and can't keep its story straight from start to end, and it starts missing requirements. Not because there's too many tokens, but it's just too many meta levels to keep track of.
Yeah.
And in that case, right now, I would say then somebody needs to go in and choose which requirements to hold back, right? So that the rest of them can go through the whole process. And then on the basis of the code you have, do another run. But that's also dangerous because, well, if you've generated code that's longer than the context window, right? That's not going to work. You see what I mean? You can no longer do the thing that we were talking about before. So really, this is kind of a hard limit. If you can't increment your way through to the scaffold, you're kind of screwed. Does that make sense?
Yeah.
Yeah, you need to get to a working, a reasonable test suite and scaffold, and then you can fill it in. But after, yeah. So, you know what? Actually, if you had that problem, you know what I would do? I would actually ask it to make me a set of modules here, and then split up the requirements by module. See what I mean? I don't know, instead of trying to find, what kind of requirements I can layer on top of this, I would try to figure out what kind of requirements I can layer under, right? What module, if it existed, would substantially simplify these requirements. See what I mean?
Yeah.
And therefore, like, try to, you know, find a subcluster of these requirements.
Well, okay, so here's the challenge, right?
Mm-hmm.
We're starting from, you know, even before requirements, right? Those requirements were generated from, like, you know, an iterative process that started with like a vague description of what we want to build, right?
Mm-hmm.
And we know that at the bottom of this tree are function implementations.
Mm-hmm.
And, you know, we're really confident that given a JS docstring and a function stub, you know, we can generate some unit tests and generate the code for that, and that's fine.
Mm-hmm.
And I feel like we're even relatively confident that, you know, given a complicated function that couldn't be done in a one shot, we could say generate me stubs for a bunch of utility functions that are called by this function, and then we can recurse there. Okay, so that gets us up to the level of complexity of a workhorse function, right? And then above that, we have class, right? So we figure, okay, we can get a class implementation, tell it to use a core function, tell it to call out to a pure function and define that pure function. Now we have another layer, which is multiple classes that are part of a library, basically. And we're missing this like meat in the middle part, which is, you know, at some point you branch out of what you can hold in the entire context size or in your complexity limit. And we have to come up with like the algorithm that's just never going to fuck that up.
I'm not following. I've tried, but can you one more time?
I guess we have clarity on how the last 2 or 3 steps of this work at the leaves, right? And we know how we start to generate requirements, right? But we need the general purpose tool that's going to split up a set of overcomplicated requirements into subsystems that can each be handled independently. Like, you can press the reset button on your set of submodule requirements and treat it, and it's another case of recursion where you're just back at the base case and you go down again.
I think you're getting there. One more time.
Okay. We know the last 3 levels of recursion were the problem is this general case of how do you parallelize work in a complicated system?
Yeah.
How do you orthogonalize it, right? And how do you do so robustly?
Mm-hmm.
Such that you can do the depth first thing and you can always roll it back up and be confident that it will work, right?
So I'm not confident it will work, right? What I want is to check if it will work, and if it doesn't, I can try again. So I'm not aiming for confidence that it will work for sure, but that I will catch it if it doesn't, and I can try again. Just to be clear.
Okay.
So that's there's always the chance that something will go wrong and it will have to retry. But long story short, after it passes the test, then I assume it worked. Yeah. Though I don't know how much of an assumption I'm making at that point.
Yeah.
Does that make sense?
Yeah.
Like if it just to make sure I've articulated it as clear as I can. If you generate a scaffold, right, and then that has a few stubs, and you go and make one stub and the test for a stub, right, stub A, let's call it, and you generate the code for stub A, and you go recurse as many levels deep as you want, right, and then fill them in and test everything, whatever, and you, long story short, you reach to the point where the scaffold for test A for stub A, sorry, the test suite for task A The the test suite for stub A and the code you generated passes, right?
Yeah.
So you take that and you plug it into the scaffold.
Yeah.
And let's say there's either no more, or you do the same thing for the other ones and you plug them all in, and then you run the test suite for the scaffold.
Yeah.
That test suite might fail, right? That's why you have a test suite at that point.
Yes.
And what you do is you basically just start again from the point of probably from the point you generated the test suite, right?
And you run the whole thing over again?
I mean, that's why you make that test suite, right? So you can check yourself against everything that came before. You basically need a checksum. Once you've done all the ups and downs,
Yeah.
and you've composed the thing, you need to know that the whole thing does work, even though, so you know that the components work.
Yeah.
But how do you know the whole thing works?
Yeah.
Right.
But the problem we run into right now, right, is that if I plug, we can get a usage example, that's fine. But if I plug the requirements and the usage example and say, give me a test suite, that test suite will not cover all the requirements.
Okay.
So, I mean, you could say, give me, you could give it the usage example and the type definitions and go through the groups of requirements and say, give me a test suite for this subset of requirements. I think you can parallelize that no problem. But then, so now you have the test suite.
Yep.
And you say, generate me the scaffold. But I mean, it's just your test suite at that point balloons to a size that it's like, it'll be 4,000 tokens.
Right.
Or greater, right?
Or greater.
Right. So the second you parallelize, basically the second you start parallelizing, you can't stop, right? Because the entire point is that you've ballooned your context outside of one thing. So now you have to keep using some sort of parallel strategy to run through everything you've generated.
And this is why I think the end-to-end test is a better thing to generate at that level, right? Than some sort of super complicated test suite.
Yeah, your smoke test, right?
Yeah. Because once you have your smoke test, the rest is about getting more detailed information. But the information of what you actually need to make is in your smoke test.
Yeah.
Right? Like, I think either fits or doesn't fit.
Really be your usage example. Your usage example and your smoke test are the same thing. It should be a kitchen sink example, sort of.
Yeah, you're not wrong. You're not wrong. Like, in a way, what I would do is I would emphasize my kitchen sink example, like you say, right? And then any spare tokens I have, I would spend on like tests, because that's not bad necessarily, right? But it's also not essential. Yeah, I think once you have a usage example in your types, you're in a pretty good place.
Your smoke test just becomes literally wrap your usage example in a describe block so that it can be invoked by test runner and put some assertions at the end of it. Like a usage example usually has like console log result, and then it tells you what the result should be. You just basically swap that for expects that are assertions of what it would tell you.
Yeah. Yeah, I see what you mean. I mean, I don't know. Maybe there are reasons to just go for, make me a kitchen sink end-to-end test instead of an usage example. But maybe some of the features of something like Jest might be of use. But I think informationally, what you care about is the actual example itself.
Yeah.
Right.
And that doubles as a way to make sure your docs are always up to date because your usage example is an executable.
Right. That's actually, you're making a fantastic point. Your usage example is both it's docs, it's test, and it's code. If
Yeah.
you think about it, right? It's sort of it's a thing that, in the Venn diagram of all the things you need for a repo, it kind of stands in the middle.
Yeah.
Um,
And it's basically it's an
and probably
embodiment.
tutorial code too. Yeah.
It's an embodiment of your requirements too.
Yeah.
It's
That is what it is.
Yeah.
Yeah. I mean, literally in some way, right? Like, because you're asking about something you can use, presumably.
Right.
So what better way to depict that than play
And
acting?
you can still because your kitchen sink example still won't have everything.
Did you say kitchen sink?
Yes, I did. Moving right along. You could still generate a super thorough test suite, right? But that becomes a side chain, right? That becomes a something that you just generate
Exactly.
the formal top level, and then that becomes something that you plug into a debug loop and just say, I have this test, it's failing, fix it.
Yes.
But in terms of the asset that you need to carry around in context, that becomes the smaller, more condensed version. Okay, I like this.
Yeah.
Okay.
So going back to our LLM and just copying from what we did last time, it's generate a thorough usage example. Probably something even better than that, right? I don't know if this is the way to do it, but because presumably there'll be a response and this will be a second prompt, but roughly.
Yeah.
But you get an example back. And then what do you do? Okay, and then we said we did the whole grading thing, right? Which was intended to not necessarily that's the same with as are you sure, basically.
Yeah.
Right. You generate usage examples until one actually hits all the spots.
Yep.
And maybe you are a little forgiving in that you try to correct it once or something. But again, I think what we found is that it's much more likely that it will do the right thing the first time than that it will correct itself the second, unless the difference is one thing or two things at best.
Yeah.
Okay. So yeah, basically you add an "Are you sure" loop here. Effectively, is what we're saying.
Yeah.
Okay. And then what? So we've got, we've got this old thing, and then you get your usage example out, let's say, right?
Yeah.
Pretty much. Okay. Then what?
Then you generate types.
Okay, so basically, like, um, are these the magic words?
Something I've tweaked it back and forth a little bit.
Anyway, whatever. We can work that out. We're still in agreement that we're still at the place where we think that the types are helping, right?
I mean, they catch things earlier, right? Because you can the second you have types and you're generating test code, I can run a type check against the test code,
Right.
and that catching that error there, like, and that catches stuff like you've hallucinated a node module that doesn't exist, or you're not using the right function.
Right. No, that sounds super helpful, because then you can actually.
It's frustrating in the moment, but it's you're facing frustration that you would face later anyway.
No. What you're doing is you're testing the tests, is what you're saying.
Yeah.
Right. You are preventing it from going down the rabbit hole to make the functions, et cetera, only to come back and plug them all in and figure out the test suite for the whole thing doesn't work.
Yeah.
Do
that with every asset at every step, right?
Yeah, and actually this opens up a new question, which is like, so let's say you are at the point where you are ready to create to run the first sort of cogen, right?
Yeah.
So okay, let's speed through it a little bit. Through this a little bit, right? So you've got two more steps, right? One step is,
and we can
basically
save you time. Let's just presume the existence of an Are You Sure loop.
Yeah, end-to-end test. Or are we not making end-to-end test at this point?
The end-to-end test is the usage example.
Okay, so then it's so I suppose what you are saying here is like
rewrite the usage example in the form of a just runnable test.
No, I'm saying like I'll just change it to say generate a thorough end-to-end usage example.
Mm-hmm.
You get your types, and so here is your cogen, right?
The bottom.
No, the one before the bottom. This one.
Oh yes. Yeah. So this would be.
Yeah.
Generate the stub or scaffold, whatever you want to call it. What I would actually say is generate code that satisfies the types.
Satisfying the types isn't everything, right?
Right, but that wording, generate code that satisfies the test, you're like, implement this, but not really. Right? You want to say generate code that matches the type definitions, leaving all implementation as JS-doc stubs.
You know what? I'm just gonna this. You'll have to experiment with this. I don't know which formulation of this. I can think of various ones. I'm not super sure that yours works better than mine, even though I know mine is garbage too. Like, we might talk about requirements. This is kind of getting to the thing I was trying to get at, right? Which is that when you get your requirements here, right?
Yeah.
So in principle, you could say here like no. Where is this? Maybe it goes. God damn it, man! Come on. Yeah. You should be able to say so. Okay, so first of all, there's a minor issue here because I was trying to avoid having to fix this, but I don't think I can. So first of all, I have to say here orthogonal requirements as a like model the LLM response as its own thing because I'm trying to model the prompts without articulating it, and it's just not. It's not working out for me. So let's say I've got these orthogonal requirements here, right? Now, and here we're like, okay, end-to-end usage example. You know what? Actually, let's just accept that too. That just kind of happens. So then my thing here is the usage example, right?
Yeah.
Learning to blind type, I'm so happy with. I'm so pleased that I did it, and it's totally counter to my character. Like every time I notice I can do it, I'm like, this actually required me to sit down and like put organized time to like train myself.
Yeah.
And if you told me now that you're gonna sit and do this, I'd be like, yeah, no, that sounds fun, but there's no way I'd ever do it.
You mean like, just typing without looking at your keyboard?
Yeah.
Yeah. I remember.
And I was old. Like it wasn't something I did like
It was
my years.
It was the rare example I have of the educational system actually browbeating us all into doing a thing that has paid huge dividends in my life.
Exactly. That it is in that class of thing where, if you like.
Yeah, if my 7th grade teacher had not put a fucking bandana over my hand and, metaphorically whipped me with the ruler anytime I peeked, I wouldn't have done it.
Yeah. I think I was in my 30s actually when I learned it. Yeah. And I just kind of decided at some point, must have been feeling really good about myself, that I would just not, type by looking at my, hunt and peck. Like you can get pretty good at hunt and pecking. It's true.
Oh, yeah.
I want to say that I didn't
once every 3 years
by hunt and peck,
my father uses
but
it.
I kind of think I did.
Yeah.
I kind of think I wrote my whole PhD by hunt and peck. So
yeah. I took it to the next level when I was in high school. I went, for a week. I thought I was going to be that kid that learned Dvorak instead of QWERTY.
Oh my god!
And I actually popped all the keys off of my laptop and rearranged them in Dvorak.
And then you figured out that not all keys are the same.
Well, and then so I did that. So my physical keyboard layout was Dvorak, and I just got so tired of it because I knew QWERTY well enough by then that I switched the software back to QWERTY, but I was too lazy to actually pop all the keys back off and switch the keys back to QWERTY.
Right.
So I had a Dvorak layout keyboard that was set to QWERTY, and one of my favorite things was, a classmate would come over and want to type something on my laptop, and they'd sit down and they'd get like a sentence in because most of my cohort could like do it well enough. And then they'd need to remind themselves where Q was or something, and they'd look down and they'd have this moment of like, ah! I'd be like, no, it's fine, it's QWERTY. It's just you got to know because you can't look down.
It's quite funny. Oh my god. Yeah, it's but you're right. We should actually collect what those tasks are because there's not a lot like where you can like literally not give a shit about how you feel about something, just like force yourself to do it, and then you get through it, and you're like, I've got the superpower now.
Yeah,
forever. Yeah. There's very few things that I don't know that I can put anything else in that category. It's weird. Like maybe driving, but I can't drive. So
right, driving or bicycle riding, I think is another one. Swimming.
Yeah. Swimming is a good one. Yeah.
I can doggy paddle, but
I learned to swim when I was very young. So I don't
really. It's the things that like you almost get for free if you tackle them at age 4.
Yeah. I mean, is this a thing in the US? Like people not knowing how to swim?
I mean, it's not part of the curriculum, so either your parents teach you or they take you to swim lessons.
Yeah, I think it's one of those things
I learned basically to the extent of like, I'm not going to drown at the rec center, right? But I never got good in any.
Oh no, I'm not saying I'm like a competitive swimmer or anything, but it's just that I realize that in Greece this is so cultural that you go to the sea every year, and it's there and it's free, right? It's not like some sort of high status thing. It's you literally, most people can just walk to the beach.
Yeah.
So, and not all beaches are amazing, but like there's enough of them that there's no real barrier.
Yeah.
And it's pretty great, even when it's not. I was actually commenting to somebody that it only dawned on me that like falling in the sea was like a bad thing when my wife was doing boating lessons here in Seattle, and they were like, you should take extreme measures not to fall in the water. And I was confused for a while. Because I'm like, why would you not want to fall in the water? Isn't that the whole point?
Right.
And they're like, well, you can get hypothermia. Right. And I'm like, oh.
Oh, that's right. Well, water is cold in some places.
Right. Like, it's just, it was completely out of my reference zone that would be a concern. So this is kind of like that. Okay. Fine. Okay. Last complete irrelevant anecdote. When I was a young boy, we had this lady that would come and help around the house with her the housework. And she was from Santorini. I don't know if you've heard that. It's a famous sort of Greek tourist island, but it is also the remains of a much larger island that used to be there before a volcanic explosion, right?
Okay.
So the very important clue to that in that island is that all the beaches have black sand.
Okay.
So she grew up on that island, right? And then she kind of came to Athens and was absolutely shocked. The beaches had white sand.
Right.
What is this? Yeah, it's so like this concept of like growing up with something that is actually like an edge case, but for you it's not, because that in your local context that's just the normal case. And then you get introduced to the world, and you're like, yeah, no, it's nothing like nothing like that. It's a fun thing. Okay, so what I was trying to say is, this is good. This is a good, mental palate cleanser.
Yeah.
Is that you could do this, right? You can do docs,
Yes.
right? Or there's other things that fit this mold, like spec, or a README, or I don't know, like a website, blah blah blah. And not only you can, but you will, right?
Yeah.
But the question is, once you have that, now in theory, you could play it this way too, right? You could feed some of that into the CodeGen. See what I mean?
Yeah.
And the question is, like, what do you do? Like, you could totally not do it, right? So in a way, if you don't do it, then that's your first branching off point, which I think you can probably get away with.
Yeah.
Right? But you could also use it to inform your CodeGen. So anyway, I'm just leaving it like that, and I think I'm going to record this one also as a dotted line. But that's what I was trying to say.
Okay.
Okay, so you generate code, blah 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 stubs. Okay, and this is the moment we're all been waiting for here, right? The branching off point. So the idea is you. Okay, let me just wipe this out. Right, and you basically what you have is something like this, right? Oh no. So,
Okay.
so each one of these is now like generate test for step 1, right?
Yes.
Step 2 and step 3.
So okay.
And then, yep, go ahead.
So here's the core thing. You've got your usage example and your orthogonal requirements in context, right here.
Yes, this is actually what I was about to. Okay, let me draw this out here because I think
there's something like there's something about the generate the stub test, right? Because the stub test should define what that function, like the tests ideally for a stub should be able to be generated just with the stub definition.
Yeah, they should.
Right.
I'm
so,
well,
such,
but it doesn't hurt to have more if you don't need the code, if you don't need the context space, right?
Right. But we're now entering into the recursion. So let's just I think it will pay us dividends if right now, I think there's something along the lines of, in the stub generation, you say the JS doc string, I'm going to say this stream of consciousness, but you come up with the prompt that adequately does this. You say the JS doc string for this stub needs to contain all the information of the parent requirements relevant to this stub, right? It needs to know that it's filtering, it's performing a lensing operation at that step. And if you do that, then you, at each layer of recursion, the stub definition includes all the relevant requirements to that stub. And then when you say generate more sub functions, you do the same thing based on the parent.
Yeah, I mean, in that sense, what you probably want to do is, instead of saying generate tests here, you want to say generate requirements, right?
Yeah.
Because once you have requirements here, then you can really ditch everything else. If you keep the code, you're like super golden, right? If you keep up to here, or even up to here, right? You're flying high. But you don't need anything more. On paper, you shouldn't need anything more than this.
Yes.
Right?
To go down.
Yeah. But basically, once you have requirements, right, you just basically just same thing. But what is it? Is it a usage example then here? Are we just recursing that way?
I don't think we need to recurse to usage example. I think once you have a stub that has its own requirements that are the complete subset of the parent requirements that are relevant to that subsection, I think you can just do a stub followed by test followed by substub followed by test followed by substub followed by implementation.
So, question for you.
Yeah.
Why do we need? Okay, I think I'm running out of time. Sorry, trying to figure out how to. Yeah. Okay. Well, I need to run, but
Can you share this with me?
Yes.
I think the win today is the realizing that the usage example should really be at a kitchen sink style, and it should be your end-to-end smoke test.
Well, the thing that I the thing that bugs me is that for some reason we are changing our game from here to here, because if the usage example is good enough for this, then why isn't the usage example good enough for this? That somehow confuses me. There must be some deep reason here, but I don't know what that would be, in a way, right? But here's the thing. Like, I made a small change here, right? I added tests here to the side artifacts that you're generating.
Right.
And so presumably you could at least generate some tests that go into the code gen, right? You have the usage and some tests. But here you got requirements, and then you've got, what did we say? Like tests. But the thing I just want to make sure before I go, we've absolutely nailed down is that whatever you do on this level you make code, right?
Yeah.
Right. And you make code, you test it against these tests, right?
Yeah.
And then you take this code and you plug it into this skeleton, right?
Good. Yeah.
The scaffold, whatever. And once you have code plugged into the scaffold from all sort of stub bits, and again, the stub, by the way, the stub thing, we could replace with some sort of like object with metadata sort of thing, right? Does that make sense? Like you could say like, I'm just trying to think like how to integrate the insight we had before about using either separate files or objects with properties in order to make functions pluggable. The stub is kind of going backwards in that regard because you're using string parsing again. But I'm skipping over that right now. But we'd need to find a way to articulate things such that they are pluggable, and ideally we skip manipulating ASTs.
Yeah.
Okay.
I did do an experiment with JS CodeShift and determined that it's not where we want to go.
Okay.
Not right now.
Oh well. Okay. So, long story short, you plug that thing back into here somehow, and once you have it all filled in, all the holes are plugged. You first of all you see if the user example runs, right? And or generate a test suite and test it with. Probably both.
Yeah.
I mean, honestly, you could probably. Well, no, but that's the problem, right? You can generate a test suite, or you can run that, because all of that happens outside the LLM context, right? The code you generate could be 10,000 tokens here. Yeah. It doesn't matter, because if your test suite if your test suite fits in your context window, and if your code fits in your context window, no. Strictly speaking, neither your test suite nor your code needs to fit in your context window.
Yes. The only thing that needs
right.
to fit in the context window is that kitchen, the kitchen sink and the type definitions, right? Because that's the presumption, is that's your core, that's your backbone. Your backbone needs to fit in the context window.
Yeah.
All the leaf stuff can be done piecemeal.
Yeah, without leaving any or much anyway on the table in terms of optimization power.
Yeah.
This is the critical bit, right? Like what happens in the functions happens in the functions, and long story short, could what's in one function affect what's in another function? Yeah, but only marginally so. And honestly, if you're doing that, you're not really encapsulating them very well. By the way, which is why when I say generate code, blah, 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 here, I would add something about dependency injection.
Okay.
So do you know what dependency injection is? Have you come across that before?
Yes, but not formally. Give me the formal textbook
definition. So the whole idea is that with dependency injection, the function is not supposed to touch any globals itself. Yeah. Right? If it's supposed to modify something, it explicitly declares it as an input.
Right.
I think that's true even for its outputs. Like it gets its outputs as inputs that it modifies.
Yeah.
Which makes the code much more like circuit-like, if you think. More Node-RED-like.
Pure functions. Yeah.
I don't know if pure function is exactly that, because I don't know if pure functions, if you get your output as inputs, or I don't even know if dependency injection requires outputs as inputs. But I guess the point is like, we probably need to dig into it a little deeper, but the big part is that it doesn't make any implicit assumptions about its environment.
Yeah.
right? Everything is spelled out in the interface. And once you realize that, you realize why it's, very compatible with the way we like to do things here, right? Because you don't want any sort of like, oh yeah, we reach into this global and blah blah blah, right? Like that is, cancer. But once you actually do that, the kinds of things that build solid encapsulation for the functions, then they really shouldn't be affecting each other, right? And if they really aren't affecting each other, then there's no point in having them in the same context window, which is basically victory, right? And victory, I mean, you don't really care at that point about being, fitting in the context window. You can make things that are larger than that with no problem.
Yeah.
Okay. The last thing is that see this a little bit. Leaving any functions as JSTOC stubs. Now, the way this is worded means that if it doesn't have function calls, right, it won't generate JSTOC stubs.
Yeah.
And if you have a way to detect that, which we should, again, we might follow different patterns to generate the same effect. But the point is, remember the thing we were saying before about how do you know when your base case is?
Yeah.
Your base case is when there's no JSDoc stubs implemented. Right? Like if it outputs just top level code,
yeah,
then you're done. You know that you've bottomed out.
Yeah.
So that's basically the whole strategy is this, right? Again, it's code gen on the way down, testing on the way up, until you've integrated everything, plugged everything in, and your main thing runs. And then again, you can do more thorough quote unquote testing, with these guys, make sure everything is fine. But long story short, if you set this whole thing up, right, like you can start with your original requirements. And the rest can go on autopilot. Like, especially after you're done with the enrichment steps, let's call them.
Yeah.
The rest should be able to go on autopilot.
Yeah.
So at that point, you just kind of have code that works, right? So in a way, so long as you monitor it until it reaches the usage example and you're happy with it, right?
Yeah.
It should be able to do the rest automatically, though if it doesn't, I think the conclusion you should reach is that you didn't do it right. Like there was something wrong about your requirements.
Yeah.
Unless it went wrong in some way, in which case we should fix our prompt strategy. And again, like, by the way, all of these likely are liable to have a critique step of some sort, right?
Right.
Okay. I think that's all of it. Or at least, if you take this recording, you can probably, all the bits and pieces that we know right now are in there. We might hit at different walls. But if we do all of this right, then the workflow that we write, the workflow engine that we write, should be able to articulate this kind of flow inside it. So there's a secondary question, which is to figure out if we have set up any patterns here that are not necessarily expressible.
Right.
Yeah. Like, for instance, I know that, this kind of like backtracking or whatever, backpropagation, whatever you want to call it.
Yeah.
No, it's not. It's probably backtracking. Yeah. Is, is probably breaking the Node-RED paradigm a little bit somehow.
Yeah.
Right. I'd probably need like backwards arrows or something. I don't know.
Yeah. Well,
But
I mean, for example, actually, this is the most obvious one is circular dependencies, right? Our requirements specifically state that circular dependencies are not allowed, right? Because we want it because the workflow should be a DAG. But any sort of backtracking or loop becomes a circular dependency. Now that becomes, I think, deal withable in that you just sort of define your little loop function. Like you define that you encapsulate your loop inside a single task that just breaks out when it's done.
Yeah, I think you wouldn't really. I think if you're seeing loops here is because we haven't done it right. You know, like, there's no real.
It's always a forward propagated loop, basically. That's what you're saying.
Well, let's talk about a simple one, right? Like, I don't know which one is this. Like generate usage example, right? Are you sure? Okay, well that's not backward, right? This one, well, what this says is like if the thing failed, right? Try again.
Yeah.
Is that really circular? I don't think it's circular actually, because circular is the thing. No, it's a different instance of the same class of task actually, because and this actually might cause trouble for our workflow language. But the problem with circular dependencies is that the way we're doing the dependency testing, it would never start because it would be waiting for the thing that depends on it, right?
Yeah.
But in this case, what we're saying is that there's two instances of generate a thorough blah. The first one does not require the results of the are you sure, and the second one does.
Yeah.
And the second one probably is also slightly different in that it, I don't know, keeps track of something or other.
Yeah.
Like some count, right? You don't want to be doing this forever.
Yeah.
But anyway, I think you've got a point that there's something missing here. But I think we'll only find out as you start to try to make all of this work. At least I think we're half on the same page. And I suspect the next thing we're going to want to do, which you've kind of done already, is to make a workflow generator.
The falafel.
The falafel. What was the falafel again?
The flow authoring flow.
Flow authoring. Right. But right?
Yeah.
So you get the thing to write you the code in the workflow language for coding the workflow language. I don't even know. At this point, I don't even know. That's not even self-hosting. Right? That's some other thing that I'm failing to pattern match, but I'm sure is a thing of some type.
Sure.
But at the end of the day, all that should be left, like if you think about it, right? We've got like three classes of requirements here, right? First of all, the first client kind of requirements is the requirements for the workflow language. The second one is the requirements for the workflow itself, right? The workflow. So the workflow generates the language. The language executes the workflow, and we just have ultimately like the thing we're maintaining is two sets of requirements.
Yeah.
And okay, this is about to get really abstract really quickly.
I'm
But
not used to that at all.
oh well, that's too sad. Too sad for you. I know I sprung it on you. But this is kind of the way human reproduction works, right? Where you've got the egg cells, the ovaries, and they've got a bunch of machinery on them, right? And that machinery gets copied onto all the other cells, like the mitochondria.
Hey, the mitochondria is the powerhouse of the cell.
That is correct.
Another thing I
But
remember.
mitochondria did not come from your dad,
Right.
right? So when they do like matrilinear tracking, what they do is they sample mitochondria because that is matrilinear.
Right.
What I mean by that is like that's not in your DNA. Weirdly enough. I mean, I don't know. I may have said something completely stupid now, but I like to the best of my understanding, you got your DNA and stuff, right? Chromosomes and all that, but like there's a bunch of machinery that just kind of goes along.
Yeah.
There's not actually being tracked in version control.
Yeah.
I guess what I'm saying is like if you got this code
mercurial repo inside of your Git repo.
Something like that. Like if you got a bunch of utilities, right, hanging around your workflow language that get attached to your generated code or whatever.
Mm-hmm.
Like those can just be like, be getting carried along and even accumulating improvements, I think, over time without formally being part of the requirements of the workflow language or the workflow.
Yeah.
Anyway, I'm pretty sure that applies to us somehow, but I'm not exactly sure how. So I'll just call it like replication machinery, right? That just is, getting copied by value everywhere. Okay, look, I think we've done a lot today. Not necessarily similar to other times, but probably more productive.
Yeah.
Overall. I think you got to access all this, see what you can make of it, and we'll continue tomorrow.
Yeah.
Thanks for your patience.
Mm-hmm. Make sure to share this with me.
I did.
Okay, cool.
Both to you and any accidental viewers who might have somehow tricked by,
Oh, did you put it in the chat? I do not see it there.
No, I like literally shared it with your Gmail.
Okay, cool.
Yeah. So, yeah, with any accidental viewers that we picked up because I titled this "Live Putin Russia Coup" coverage, which I didn't. But if I did, okay, all right. Have a good evening, and we'll talk some point tomorrow as usual.
Sounds good.
Bye, everybody.